Thank you for this opportunity. I'm going to talk about how we are going to make masks that could be antiviral. The main route for the transmission of microbes such as viruses and bacteria are through the airborne transmission. And these microbes can cause severe diseases such as pneumonia, influenza, and in 2020, it was declared that COVID-19 causing virus, SARS, coronavirus 2, is also transmitted through airborne. Metals are often used as antibacterials, and they have several applications in healthcare settings, such as in the constituents of textiles and wound dressings and coatings. And the most known antimicrobial metals are zinc, copper, and silver. And silver pronounced the most efficient so far. Whether these metals are also effective against viruses, however, has been less studied. But due to the coronavirus outbreak in 2019, this issue has gained more attention. So why should nanoparticles be good candidates to fight viruses? Is that they have these special material properties, and with modifications, we can give them a charge, positive or negative. We can modify their size, and of course, their concentration that should dictate their efficiencies. In our study, we used nanoparticles composed of copper oxide, zinc oxide, and their corresponding salts. And we tested them against gram-negative and gram-positive bacteria, which are also hospital-associated infectious causing bacteria, and tested against influenza A virus and SARS coronavirus 2. And here I'm going to show you very preliminary first results that we obtained with these substances in suspensions. And to our surprise, we actually also tested silver, but silver was not so much efficient against influenza virus. So we decided that we will proceed with copper compounds. And we are going to incorporate these compounds in fiber materials consisting of polymers. To do this, we use a method called electrospinning. And to produce these fibers, these nanoparticles are blended in polymers. So the polymer solution contains of dispersant, polymer, and nanoparticles. And we tested these dispersions via DLS method to see if there are big agglomerates in the solutions. And there were some technical issues that needed to be addressed to produce these fiber materials. And that's why we chose first nanoparticles. And why it's relevant to do these fiber materials is that we can incorporate them in masks. Masks have different layers, outer and inner layer, and our nanoparticles in filter materials could be in the middle layer. And the idea was that when these masks are in front of your face, and then in contact with the virus is inactivated. And basically, on the market, there are two types of masks. One mask is that protects yourself, and the other type of masks that protects the others. And our idea was to manufacture masks together with an industrial partner that could protect yourself. masks that have antiviral properties have been produced previously as well. And it's essential that these masks that we are going to make have good air permeability, they have good particle filtration properties, and their fibers have relevant strength so that they don't break very easily. And here is an example of a mask on the market containing copper oxide nanoparticles. And here you can see that there is actually a lot of metal there in the fibers. Due to the technical issues, we were able to produce up to 10% copper content in these fiber materials. And we first tested them against bacteria. And here you can see the first results, showing that indeed the antibacterial efficiency was already at 2.5% of metal against these both bacteria. And copper sulfate was even, as an ionic copper, was even a better antiviral against influenza virus. We also decided to test this compound in these fiber materials. And our maximum rate we could obtain was 7.5% of this substance. And it was also efficient against this hospital-associated bacteria. Hospital-associated infections causing bacteria. We also tried these filter materials to test them. Next step would be to test them against viruses. And influenza virus itself is very similar to coronavirus. So it's suited as a model for this preliminary testing. But due to the facilities and access to these facilities for BLS3 laboratory that will be ready soon in Tartu, we had to do the first experiments with this model virus. But hopefully in a few months we can also test these materials against coronaviruses. So this applied research has been done together with several partners from Tartu University, Tallinn University of Technology, and National Institute of Chemical Physics and Biophysics, and an industrial partner, Esfil Techno, and that is situated in eastern part of Estonia and has a long experience in producing filter materials. And we are hoping to produce the first prototypes in autumn. Thank you for your attention.
Thank you very much. Questions, please. We have a question in the chat. What is the cost of a mask?
Well, this is a very good question. Thank you for this. We haven't actually calculated this cost yet, but it should be a very competitive price, as we are using rather cheap materials. For example, these copper oxide nanoparticles, they were sold on Alibaba for a kilogram, like something 100 euros or something. And they can, it's used only up to 10% or so.
Thank you. We have one more question in the chat. Are the nanoparticles inside the fibrous structure or in the outer layer?
Yeah, they are inside the fiber structure.
And one more question: can the masks be reused?
Yeah, we hope so, because one idea was to produce really these environmentally safe materials, and it would be great if we can use it several times, but we have to test it. For example, silver-based materials, they can be washed up to 100 times, and they retain their antimicrobial properties. But in the case of masks, it might be a little bit more complicated due to the infection risk as well.
Thank you.
But
yeah, I have to ask one last question. Came from the chat. What about the toxicity on mammalian cells?
Mm-hmm. And this toxicity of these fiber materials containing these nanoparticles, it's not obligatory to do this testing for regulations, but there is a possibility that they have a toxic effect on the mammalian cells as well, but we haven't tested it yet. We have tested these compounds separately in suspensions in previous studies, and actually copper is less toxic than silver, so it could be a high potential for these copper-based materials. Mm-hmm.
Okay, thank you very much.